Hello everyone, here the Portier Keyonthego Captain Group, and today we will like to present our project brief. Here are the members of our team: Kelvin, Futuh, Rahmat, David, Luis, and Ken. And these are today's agenda. We heard about the project, and then demo, implementation, listening, and the last one is budget and performance. Next slide. Current system limitation. The existing system has several key limitations: reliance on desktop-based application, limited accessibility, inefficient in adapting to modern. Next slide. So the solution proposal. Our proposed solution is a mobile and cloud-based system designed for portable signature acquisition. This approach eliminates the reliance on static desktop application, making the process more adaptable and efficient. Project goals. The goals of this project are to enhance operational flexibility by enabling mobility, address and overcome the current limitation of the existing system. That's all from me.
Okay, for the requirements, there's a for mobile development, there's a UI designed using with Figma. For the authentication, using Authentic as the third-party authentication provider. And also for feature development, there's a sign request. Also, it's divided by two: authenticated user and also unauthenticated user. Also, we send the data using including the signature in base64 format, also the position of the users. Also, we support multi-language support using which German and English. Also, we have a history feature, also divided by two, and also API integration from front end to the back end. And for the requirements for cloud computing, there's an API contract. It's using OpenAPI 3.0, also RESTful API using AHO and PostgreSQL, observability using Grafana, deployment using Google Cloud, and containerization using Docker. And this is the demo video. Hello, I'm Kevin Lim. I'm the representative from the Keyonthego team for the demonstration of the project or the mobile app application. So the first screen in our application is the welcome screen. Here, user can choose whether they want to log in or process an investment. So before I start to demonstrate the sign-in feature, I'm gonna explain a little bit of the authentication flow with Authentic. So first of all, the mobile is gonna redirect to the Authentic to fill in the credentials. And finally, from the Authentic, it's gonna do some deep linking to the mobile app to the return of code parameter. And in the mobile, we're gonna do some request access token to get the GWT. And finally, the backend gonna return the access token or the GWT containing the user ID. So if the user select the login option, they will be redirected to the login port. So I'm gonna demonstrate it. I'm gonna click the sign in, and because I have tried to sign in, so I still got my session saved to the application, so I don't need to fill in my credential anymore. So from here, we move to the main part of the application. So our application begins with the homepage, which displays a list of pending sign requests, and also the user can view the statistic. Although this feature is still under development, so we are gonna go to the scan menu. The user who are not logged into the application can scan a QR code to submit a sign request. So this feature is only used for the unauthenticated. And now we're gonna go to the profile menu. So in this menu, the users can view their account information and switch the app language between English and German. And now we're gonna go to the history page. So in this page, the user can view their sign request history, and also for the login users, this data is fetched from the backend. While for the non-logged-in users, the data is stored locally using ASAN storage. So if you open one of the card or the data, we can see the data of the send request, like the location and the key holder and the status, and also the created app. And finally, we have the sign request feature. So when the sign request is created from the backend, it will appear in the mobile app. But this is only appear for the authenticated user. If the user is not logged into the application, it needs to scan the QR code that they got from the backend. So I'm gonna try to put this issue. I just need to put my signature and then click submit. And finally, it's gonna make the issue sign, so you can see the history back. So this is the issue that we have created. Okay, that's for the authenticated user. I'm gonna try the unauthenticated user. Here, you just need to scan the QR that we got from the backend. And finally, we got the request from the backend. I just need to signature it also, and then click submit. So after submit the sign request, you're gonna see the history page, and this is all the history that I have created or the sign request that store locally to the mobile application using the aside storage. You can still open the detail of the request and see all the data that we got from the backend. So before I demonstrate the Grafana, let me briefly explain how it works. So the mobile app connects to the database server through the internet. And then the Grafana is gonna display the data that collected by the Prometheus and the Loki through data scraping. So that's the simple way how to explain the backend works. And now I will demonstrate one of the feature, which is a Grafana dashboard. As you can see in here, everything that got requests from the API endpoint gonna be logged into this Grafana dashboard. For example, this post method that I created for designing requests. So if you actually refresh, you're gonna see a lot of things in here because everything that hit to the endpoint of the API is gonna be logged to here. And the data that we got from this Grafana is get from the data scraping from the Prometheus and Hope. So I think that's all for the demonstration of the application. Thank you for your attention.
All right, I will take over for the next section. Now, as demonstrated by Kelvin, the users can access the service via the mobile application to get and sign a sign request, but the flow doesn't start there. It starts from Portier Vision, the company's on-premise desktop application that will first get the relevant employee data and create a sign request with it. The desktop app then will get a QR code that can be scanned by the mobile application, which can be decoded into request ID. The request ID then can be used to get the corresponding employee data and sign the sign request. Next is the flow of acquiring an access token from Authentic, which has been discussed by Kelvin in the demo. The access token then can be used to access protected endpoints on the backend. When the backend receives a request, it will verify the token with a public key from Authentic. If the token is valid, the request will proceed, and it will be stopped prematurely if it is not valid. After understanding the general data flow of the application, let's discuss the main goal of Keyonthego service. Its goal is to serve requests from mobile and desktop clients and store data related to site requests. And here's the service's infrastructure, and it is shown in the diagram. This all is provisioned using Terraform.
The mobile site offers features such as geolocation tracking to record where signatures are made, and multilingual support for broader accessibility. By moving away from static desktop application, the app provides users with a flexible and practical solution to meet modern operational needs.
And for the detailed solution, we designed a RESTful API with OpenAPI 3.0, ensuring clear schema to prevent future issues. For the backend, we choose Eco Framework to integrate smoothly with Keyonthego codebase, and PostgreSQL for its reliability and scalability with complex data. Here's the endpoint and our portier banner when we start the application. For monitoring, we use Grafana for dashboard, Prometheus for metrics, and Loki with Promtail for logs. These open source tools offer system health insight, real-time metrics, and logs, keeping costs low and troubleshooting easy. Now check out our Grafana dashboard here. The app and database were deployed on Google Cloud, with database restricted to internal access for security. We choose a self-hosted database over Cloud SQL to save costs, as high availability wasn't critical. The app was containerized and deployed to Cloud Run for easier vendor migration. Now here's a view of our Google Cloud infrastructure. Use Terraform to manage infrastructure as code with script automating app and database setup. Terraform output were integrated to streamline deployment. Alright, now let's review our Terraform configuration.
Our app was designed with user in mind, using tools like Figma, React Native Expo, and Tamagui. We built an intuitive interface that's consistent across the platform. Authentication is powered by Authentic, ensuring secure delinking login flow. The signature process is enhanced with API integration for encrypted data transfer and geolocation tracking. History is synced to backend for authenticated user or stored locally for guests. Multilingual support through the internationalization library ensure accessibility for global users. Finally, tools like Sentry and Firebase Analytics guarantee observability and performance optimization, making this app both robust and user-friendly.
All right, another thing haven't been mentioned so far is the cost. How much does it cost to run the infrastructure of the application? Using Google Cloud Pricing Calculator, the estimated cost is $22.66 per month, with the details shown on the slide. Our team has also tested the performance of the application with this configuration, and the result can be seen in the slides. It is shown that the application performs well since the average response time is 75 milliseconds. So, what are the key takeaways of this presentation? Our team has successfully fulfilled all requirements from both business and technical side of things, which means that this project has been successfully completed. And that's all for our presentation. Thank you for your time.